Okay, guys, I think there is a need for my class to understand potential divided circuits a little bit better because of the questions that I've been receiving recently from your WhatsApp groups. And I realized that a lot of your understanding on how potential divided circuits work is lacking, right? So that's why I need, or rather, I felt the need to produce such a video just to refresh, if you guys still don't understand. But at the end of the video, if you still really don't understand, you can post it up in the comments, or if you want, you can actually see me in class, and we'll talk about it. All right. So anyway, a potential divider circuit. Basically, you need to be able to recognize whatever circuits given to you during the exams that it is a potential divider circuit, right? So how do you realize, or how do you know it's a potential divider circuit? As long as there are two resistors in series like that, there will be a voltage being tapped into the circuit. The thing is that if you remember that the potential difference across here, V0, this is the base voltage, and then this is the uh, or rather the input voltage, right? So here you have a potential difference, right? And let's do a numerical value, right? So if I do it, let's say, okay, let's say I put a 12-volt source, right? So this is 12 volts over here, all right? Now, if let's say resistor 1 and resistor 2 are equal to each other, right? The resistance value of R1 equals to R2, then basically they divide the potential difference across both resistors equally. So we know that, okay, if I were to put a voltmeter across R1, all right, I would be able to register 6 volts in theory, all right? And of course, because this is also another potential difference, that, or rather, it has to consume energy as it crosses through R2 as well, and because the resistance of R1 equals to R2, and therefore the potential difference is also the same across R2, right? So this is again 6 volts, 6 volts. So basically, it has been divided into two parts. All right, so that's the resistance 1, resistance 2. Now, what happens if the resistors are not the same? All right, that means we change the resistance on each resistor, right? So let me just give you values. All right, so for example, now R1 is not R2, right? R1 is not R2. So if I were to put, okay, let's say R1, let it be 10 ohms. How do I insert the symbol? Hmm, okay, never mind. Let me just write it in ohms. Right. So R1 being 10 ohm, all right, and R2 being 20 ohms. Now this shows that the potential difference between R1 and R2 is no longer the same, all right, and sorry, the resistance between R1 and R2 is no longer the same. So what happens to the potential difference? Now, again, if you remember that potential energy, or rather the potential difference is basically the difference in potential energy between the 2 points of the circuit, right? So usually we measure it in terms of parallel. So we say that, okay, the potential difference between this point and this point, uh, there will be a difference in energy levels, all right, or potential energy in this case, right? So as current flows through the resistors, they take up energy as they cross the resistor, and therefore there is a difference in energy levels, and therefore we can say, or rather we call them potential energy difference, right? Now, so if let's say it for 10 ohm resistance means that this is actually an obstacle that's easier to cross compared to a 20 ohm resistor, because this will take more energy to cross, right? But the thing is, when they split the potential, it's actually divided into two parts, all right? But in this case, what are the ratios of it, right? So again, the total potential difference between V in and V base is 12 volts, right? So what would be the potential difference between R1 and R2? You can pause the video if you want, and then you can work it out yourself. Um, but if you want to know the solution, just listen on, right? Now, so in this case, you will need to do some minor calculations, right? What is the total resistance between these 2 points, right? In series, we know that we need to add the resistance of R1 to R2, and you get what we call RT, right? So RT total, in this case, equals to 30 ohms. Right? Now, so what we're saying is that, okay, if RT was 30 ohms, it takes 12 volts to cross RT, or rather the potential difference across the 30 ohms is actually 12 volts, all right? So therefore, what is R1, right? So R1, R1, right, over, over RT is basically the fraction of how much resistance of R1 alone across the whole resistors circuit, right? Or rather the whole total resistance inside the circuit, right? So it's a fraction of this, right? Now, it is also divided by the fraction, right? So if I want to know what happens in V1, right? So R1 will correspond to V1, the amount of potential difference across V1, right? And again, this is divided by the total voltage, which is VT, right? Which is 12 volts. Now, this ratio, right, is actually equal to each other, right? So just put a big equal sign, okay? And this ratio is actually equal to each other, okay? From here, you can actually do a simple calculation, all right? In this case, R1 is 10, all right? So let's take 10 divided by 30, all right? And of course, this is equal to, all right? Now we don't know what V1 is. Let's just keep V1 on top here. And of course, VT is 12. Right? So in this case, we could actually do the simple calculation, right? So this is actually just 1/3 of 12 volts. All right, so therefore we can work out that V1, all right, equals to, if you do the simple calculation, what do you get? 4 volts, right? Now, well, that's if we calculate R1, right? But most of the time, they ask you to calculate what's happening at the V out, because this is the potential difference that we want, all right, to power whatever circuit that is, expected to work over in this side of the circuit, right? So this is the input circuit, this is the output circuit, and we want to get something powered up over here, based on the volt that we want. All right, so we're going to adjust this. All right, so if you do the calculation for V2, you should be able to get 8 volts. All right, now I'm not going to work it out here. You can work it out yourself. There are two ways to do that. Of course, we know that R1 plus R2 equals to RT. All right, so having do that, okay, we can also draw the conclusion that therefore V1 plus V2 equals to VT. All right, so you can use that. Or if you want to do the calculation like how I did over here, instead of calculating R1, let's calculate for R2, hence we get V2, right? And then we can actually do the calculation for what is the out potential difference on the out circuit, all right? Now that's only one part of it, all right? what if we want to apply potential difference circuits? All right, so let's apply it with the use of an LDR. We know that LDR is a variable resistor, all right, and it varies with the intensity of light, right? If you provide light to it, then the resistance of that resistor actually drops. If you do not provide light or in the dark, the resistance of the LDR increases quite significantly. All right. Now, so let me just move this to the side. All right. And let's take a look at how we can apply this. All right. So again, let's work with 12 volts for the input. All right. Now, so having 12 volts on the input, and let's do a fixed resistor here. All right. Let's put it at 100 ohms. Right. So 100 ohms on this resistor. All right. Now, let's say, let's block out the light first. All right. So, okay. Let's block out the light. Okay. So there is no light at the moment. And what happens is, okay. I find a way to pause this. Okay, never mind. Let me just continue and then we'll finish this real quick. Now, so if there is no light, then the resistance on this resistor would increase. So let's say it goes up by 1,100 ohms. Now, if that's the case, the resistance now at the LDR is 1,100 ohms, right? So what is the voltage on the output? All right. So the voltage on the output can be calculated, right? So in this case, let's call V out. All right. Now V out again over the input voltage, which is 12 volts, or rather the total potential difference across these two parts, right, will equal to, all right, 100 ohms, sorry, 110 ohms, right, because this is parallel to this, right, therefore this would have the same potential difference, right, over, sorry, over, now we're looking at the total resistance over here. So the total resistance of the circuit would be 1,200 ohms, right? And that would work out, so that V out would give me, well, you fill in the blank. All right, you should be able to work this out yourself. It's already given here in the mathematics, right? Now, what happens if we suddenly have light, all right? And when the light comes, all right, then the potential, sorry, the resistance of the resistor on the LDR actually drops, and it drops significantly, all right? So let's say now it drops to 500, sorry, 500 ohms. Right? So what is the potential difference on the output in this case, right? So again, you can actually just do a simple calculation, right? Now this is 500, all right? Now be very careful because now the total resistance of the whole circuit also has changed. And therefore this is no longer 1,200. This is now 600, right? From here, you can actually calculate the V out again, all right? So what happens, right? So sometimes they'll ask you, what's going to happen if the LDR now receives light, right? All you need to say is either potential difference has dropped or has increased. You tell me, all right, if it has dropped or increased, all right? Now there is one last thing I probably want to cover with you, which is a slider, all right, application with sliding variable resistors. Now this is a rheostat, And depending on how you want to arrange it, all right, you'd realize that actually there are two resistors in play. All right. So if you look at this part, this is labeled X. All right. So this is one resistor, and this is labeled Y, and this is another resistor. Right. Now we can slide this one up or down. All right. So if you do slide up, all right, then you get X to be shorter. All right. You get X to be shorter, and sorry, and Y would be longer. All right. So if that's the case, you're increasing resistance on Y and you're decreasing resistance on X. All right. Now, so what is the effect on the V out? All right. So let's take a look at when it slides up. Right? When the slider goes up, all right. So what are the implications when the slider goes up? All right. So let's take a look at the first thing. You realize that resistance of X increases. Resistance of Y increases. Total resistance stays the same. Right? And hence, if you were to look at the V out, what do you think? Yeah, increases. Now, you tell me based on what you understand in the previous parts of the video, how this works, right? So when it goes up, all right, when it goes up, right, you realize that V out increases. Why? Because the potential difference over here, parallel circuits, right, potential difference across here and potential difference across here would be the same. So if there is a bigger resistance over here, therefore the potential difference between this point and this point has increased, and therefore V out will also be increased, right? Now what happens if we slide down, right? So now if X is, if Y was shorter, if Y were to be shorter, and we had X being longer, sorry, right, X being longer, then this is actually what happens when it slides down, right? So now if we were to have it by sliding down, so you tell me, all right, so implications here, resistance of X, well, what happened to X? X has increased, right? Resistance of Y decrease. The resistance is the same, so therefore V out decreases. All right, I hope I made this video a bit clearer for you guys to understand. I think that is all I need to say for today. Thank you.